Hello, and a very quiet welcome to you, listening here on the Sleepy Universe channel. I'm so deeply glad you found your way to this peaceful space tonight. However your day has been, whatever thoughts are still circling in your mind like distant satellites, this is your time to let them go, to release them into the vast, forgiving darkness. There is nothing more you need to do now. Nothing to plan, nothing to solve. Your only task is to breathe, to listen, and to allow yourself to drift. Tonight, we will embark on a gentle journey through the night sky. We will explore 100 quiet truths, 100 whispered secrets of the cosmos above us. This is not a test. There is nothing to memorize. Let these facts wash over you like a soft, dark wave. Some may linger in your mind for a moment, painting a picture. Others will simply be a soothing sound, a rhythm of words to guide you from wakefulness into dreams. So, wherever you are, make yourself completely comfortable. Let your body sink into the mattress, feeling fully supported, fully held. Notice the gentle weight of your eyelids and allow them to grow heavy if they are not already closed. Feel your breathing beginning to slow, to deepen, in and out. Each exhale, a release of the day's tension. Each inhale, a breath of calm, starlit air. Picture us lying side by side in a vast, open field, far from the glow of any city. The grass is cool beneath us, and the air is still. Above us, an infinite velvet tapestry is unveiled, dotted with countless points of light, each one a distant sun, each one a silent story waiting to be heard. We are safe here. We are small here, in the most comforting way possible. And just before we begin our celestial journey, if this quiet space, these starlit stories, help you find the peace you need to end your day, consider liking this video and subscribing to the channel. It is a gentle way to support this community of sleepy souls, helping others just like you find their way to this calm. We are a constellation of dreamers, scattered across the globe, drifting off under the same ancient starry sky. Now, let your awareness float upwards, through the ceiling, through the whispering atmosphere, and into the deep, quiet, and welcoming darkness of space. Let the sounds of the world fade away, replaced only by the sound of this voice and the vast, comforting silence between the stars. Let us begin. The stars you see are not just specks of light. They are distant suns, each one a furnace of nuclear fusion, burning millions of miles away. Let this idea settle gently in your mind for a moment. That tiny, shimmering point of light is not a mere decoration on a dark ceiling. It is a sun, a colossal sphere of searing, incandescent gas, where in its core, atoms of hydrogen are crushed together by immense gravity, fusing into helium and releasing the energy that floods the cosmos with light. That gentle twinkle in Cassiopeia, a sun. That steady glow in Lyra, another sun. Every single one, a raging, beautiful inferno, a powerhouse of cosmic energy. And you, from your quiet, small world, are connected to each of them by the most fragile, beautiful thread, a photon of light that has traveled across the void for years, decades, centuries, just to meet your eye and spark a moment of wonder in the dark. The familiar constellations, Orion, Ursa Major, Leo, are not families of stars bound together. They are chance alignments, a beautiful trick of perspective from our point in space. We humans are pattern makers. We look up at the chaotic splatter of stars, and our minds instinctively draw lines, connecting the dots to form pictures from our myths. A great hunter, a mighty bear, a regal lion. But these patterns are a beautiful illusion, a celestial canvas painted from our unique, fixed vantage point. The stars that form the belt of Orion are not neighbors. They are distant strangers, sailing through the galactic ocean on their own solitary journeys. One might be a mere 800 light years away, while another is over 1,300 light years distant. But from our garden on Earth, they line up to form a perfect, straight line, a celestial marker that feels personal and permanent. There is a deep comfort in this illusion, a reminder that the stories and the guidance we find in the sky are a gift from our particular place in the universe, a personal map drawn in light, just for us. The sky is not a flat ceiling, it is a profound depth, a three-dimensional ocean where stars near and far layer over each other, creating the illusion of a dome. When you gaze upward tonight, try to feel the depth. You're not looking at a flat, painted surface. You are looking into an ocean with no bottom and no shore, where distances are so vast they become almost meaningless to our human senses. The stars are not placed on a single sheet of black paper. They are scattered through an immense dark volume. That bright blue-white star might be a mere handful of light years away, a close stellar neighbor, while the faint reddish star right beside it could be a distant giant, thousands of light years farther into the galactic abyss. You are peering into a natural deep field photograph, where every point of light exists at its own unique depth in the cosmic sea. So let your mind explore that depth as you drift off. Don't just see the sky. Feel yourself falling into it, slowly, peacefully, layer by layer, star by star, into the infinite, peaceful quiet. The North Star, Polaris, has not always been our guide. Because the Earth wobbles on its axis over 26,000 years, different stars take turns being the pole star. We think of Polaris as the constant, the unchanging point around which the entire northern sky gracefully rotates, a fixed nail in the spinning celestial sphere. But even this steadfast sentinel is temporary in its role. The Earth spins like a slow, wobbling top, a gentle motion known as precession, tracing a great, slow circle in the sky every 26,000 years. Long ago, when the great pyramids of Egypt were being built, the star Thuban in the constellation Draco held the honor of the North Star. And in a distant future, 12,000 years from now, the brilliant blue-white star Vega in the constellation Lyra will take its place as the pole star of Earth's northern hemisphere. It is a slow, graceful dance of our planet, a cycle so vast it dwarfs all of human history, a quiet reminder that even our most constant, reliable guides are part of a gentle, endless, and predictable change. When you look at the faint, blurry smudge of the Andromeda galaxy, you are seeing light that left on its journey to your eyes over 2.5 million years ago. Let the weight of that thought settle in your mind, not as a burden, but as a peaceful, humbling truth. That soft, fuzzy patch of light, visible to the naked eye on a clear, dark night, is not a star. It is an entire island universe, a sprawling spiral of over 1 trillion stars, much like our own Milky Way. And the individual photons of light that are landing on your retina tonight began their epic voyage long before humans as we know them ever walked the earth. They departed when the ancestors of humanity were taking their first tentative steps on the African savanna. For 2.5 million years, these messengers have been racing through the empty, silent void, uninterrupted, carrying this silent, luminous postcard from a distant cousin galaxy. And tonight, that message, older than our species, ends its unimaginable journey by meeting your gaze, here, now, in the quiet of your room. You are not just looking at a distant object, you are looking directly into deep, deep time. The planets, whose name means wanderer, do not follow the same fixed paths as the stars. They drift slowly through the constellations of the zodiac on their own silent schedules. The ancient astronomers of Babylon, Greece, and China watched the sky night after night and saw that most lights were fixed, turning in a perfect, predictable clockwork wheel. But a few had minds of their own. They wandered. They would slow their steady pace against the starry background, pause, reverse their course for a few weeks in a motion called retrograde, and then continue on their way. They named them planets, the wanderers. Jupiter, Mars, Venus, Saturn. They do not stay within the familiar, fixed patterns of the constellations. They are independent travelers, moving along the ecliptic highway, visiting the constellations of the zodiac one by one, month by month, year by year. Tonight, as you rest, one of these wanderers is likely drifting between the fixed stars, a slow, steady pilgrim on an ancient, predetermined path. A reminder that even in the apparent order of the heavens, there is always motion, always a gentle, predictable change, a quiet dance happening just above us. The color of a star tells you its temperature. Blue stars are scorching hot and young. Red stars are cooler and often ancient. Our yellow sun is a comfortable middle age. The night sky, if you look carefully, is not simply white dots on a black background. It is subtly painted with color. The fiery, piercing blue-white of Sirius, the dog star. The calm, steady yellow of Capella, the gentle, warm orange of Arcturus, the dull, smoldering red of Betelgeuse in Orion's shoulder. These colors are not mere decoration. They are a direct, visible stellar thermometer. A blue star is a raging, youthful inferno, burning its hydrogen fuel with a furious, intense heat, often tens of thousands of degrees hotter than our sun. A red star, by contrast, is an older, cooler giant, burning its remaining fuel slowly and patiently, its surface a relatively cool, ruddy glow. Our own sun shines with a steady, life-giving yellow light, a middle-aged star in the long, stable prime of its life. The sky, then, is a canvas painted with the temperature and age of suns, a quiet, beautiful display of stellar life cycles, from the blazing, energetic birth of blue stars to the slow, smoldering old age of red giants. There is no sound in the vacuum of space. The majestic nebulae and colliding galaxies unfold in perfect, profound silence. Imagine for a moment the most violent, the most energetic events in the entire cosmos. A supernova explosion tearing a massive star apart from the inside out. Two entire galaxies, each with hundreds of billions of stars, merging in a slow-motion gravitational dance over billions of years. The eruption of a solar flare from a star's surface, looping trillions of tons of plasma in great arching prominences. Here on Earth, such events would be deafening, a roar that would shatter the world. But in the vacuum of space, there is no air, no medium to carry the pressure waves of sound. They happen in absolute, perfect, profound silence. It is a silence so deep, so complete, that it is almost a presence in itself. The universe is a vast, silent movie of unimaginable scale and power. All that fury, all that beauty, all that cosmic energy is expressed only in the language of light, gravity, and radiation, without a single whisper. As you drift to sleep tonight, embrace that cosmic silence. Let it quiet the internal noise of your own mind. Let the deep, resonant silence of the stars become your own silence. The moon is not a source of its own light. It is a mirror, gently reflecting the light of our sun, a pale, silent echo of the day. The gentle, silvery, almost magical light that washes over the landscape on a clear night, that casts long, soft shadows and turns the world into a monochrome dreamscape, is not the moon's own glow. It is borrowed light, second-hand sunlight, photons that left the sun's furious, roiling surface, traveled 93 million miles through the void to the moon, and then bounced off its dusty, cratered, ancient surface for the final 240,000-mile journey to Earth. The moon is a cosmic reflector, a tranquil, pocked mirror in the sky. It takes the harsh, direct white light of the day star and softens it, diffuses it, scatters it, turning it into something gentle, something poetic, something that illuminates the night without dispelling its soft mysteries. The moonlight that touches your face or filters through your window is a quiet, delayed echo of the day, a peaceful reminder that even in the deepest darkness, we are still connected, indirectly, to the light. The Earth's atmosphere, which gives us life, also bends and blurs the light from stars, making them appear to twinkle, a gentle, constant shimmer. The beautiful rhythmic twinkling of the stars is not a property of the stars themselves. It is a gift, a filter, provided by our own living planet. The blanket of air that protects us, that gives us breath, is not a still and static thing. It is a turbulent, shifting, dynamic river of gases, with layers of different densities and temperatures constantly moving and mixing. As the steady, pure light from a distant star passes through this moving, rippling medium, it is bent, twisted, and refracted in countless tiny, random ways. This causes the star's image to dance, to shimmer, to flicker in both intensity and color, sometimes flashing red and blue. It is our atmosphere, painting movement and life onto the otherwise static canvas of the sky. That gentle rhythmic twinkling is the signature of our living, breathing world upon the pristine light from the cosmos. It is the sky coming alive, a soft visual lullaby, a constant, gentle reminder that we are looking out at the universe from within a fragile, beautiful, and dynamic bubble of air. The vast emptiness between stars is not truly empty. It contains wispy clouds of gas and dust, the raw material for future stars and planets. When we gaze into the seemingly black voids between the stars, we are not looking at nothingness. We are looking at a diffuse, almost imperceptible ocean of raw potential. Drifting through the galactic arms are enormous, cold clouds of molecular hydrogen and microscopic dust grains made of carbon and silicates. These clouds are the cosmic nurseries, the reservoirs from which new solar systems will one day be born. They are faint and invisible to the naked eye, but they are there, a thin, ghostly haze of creation, filling the spaces between the bright points of light. Within these dark, quiet wombs, gravity patiently gathers material, and in millions of years, a new star may ignite, beginning the cycle all over again. The emptiness is, in fact, a canvas of possibility. The force of gravity, which holds the planets in their orbits and galaxies together, is the same force that gently holds you in your bed tonight. The same invisible, mysterious pull that keeps the Earth circling the Sun, that binds the Milky Way into a spinning disk, that guides the dance of galaxy clusters across the cosmos, is acting upon you in this very moment. It is the force that gives you weight, that anchors you to the floor, that pulls the blanket around you with a comforting pressure. There is a profound unity in this. The grandest cosmic force and the most intimate, personal sensation are one and the same. As you feel the gentle pull of the Earth, remember you are feeling the same force that sculpts the universe, a quiet, constant embrace that connects your small, quiet room to the dynamics of the entire cosmos. The light from the sun takes about 8 minutes to reach us. You are seeing the sun not as it is, but as it was 8 minutes ago. Every time you see the sun, whether in the brilliant blue of the day or the soft glow of sunrise, you are looking into the past. The light that warms your skin and illuminates your world began its journey 8 minutes earlier, racing across 93 million miles of space at the universe's ultimate speed. You are never seeing the sun in its present moment. You are always witnessing a history that is already 8 minutes old. If the sun were to suddenly vanish, we would not know for 8 minutes, continuing to orbit and bask in the light of a star that had already ceased to exist. It is a gentle reminder of the finite speed of light, and that all we see in the sky is a beautiful, delayed tapestry of what was. The planet Venus is so bright, not because it is large, but because its thick clouds reflect sunlight with astonishing efficiency, a brilliant evening and morning sentinel. That dazzling, unwavering beacon you see in the western sky after sunset or in the east before dawn is not a particularly large world. It is Venus, shrouded in a thick, global blanket of clouds made of sulfuric acid. These clouds are exceptionally reflective, bouncing back over 70% of the sunlight that hits them into space. This makes Venus a brilliant mirror in the inner solar system, outshining every other star and planet in the night sky. It is a world of extremes, a scorching, crushing hellscape on its surface. But from our distant vantage point, it is the most serene and beautiful point of light, a silent, brilliant lantern hanging in the twilight, its harsh reality hidden behind a perfect, reflective veil. The planet Jupiter, with its great red spot, is a storm larger than our entire Earth, a tempest that has been raging for centuries. The largest planet in our solar system is a gas giant, a world without a solid surface, a swirling tapestry of colorful cloud bands, and within that chaotic atmosphere, a massive, ancient storm churns. The Great Red Spot is a hurricane-like system so vast that our entire planet Earth could fit inside it. Winds within its crimson boundaries howl at speeds that dwarf the most powerful tornadoes on our world. And this storm has been observed for at least 400 years, a persistent, swirling monument to the dynamic and violent weather of the outer solar system. It is a reminder that the planets are not static marbles in the sky, but active, stormy, and ever-changing worlds. Saturn's rings are not solid. They are composed of countless billions of ice particles and rocks, each in its own orbit, a shimmering cosmic ballet. When you look at Saturn through a telescope, you see one of the most sublime sights in the solar system, a perfect, elegant set of rings encircling the golden planet. But these rings are not a single, solid disk. They are a vast, sprawling field of countless individual particles ranging in size from tiny grains of ice to chunks as large as houses. Each particle is a tiny moon in its own right, orbiting Saturn in a harmonious, circular path. The rings are incredibly thin, only about 10 meters thick in most places. What we see as a solid structure is in fact, a beautiful illusion, a shimmering, countless-membered ballet of ice, dancing in perfect unison around their giant host, a dance of pure geometry and light. There is a point in the sky called the zenith, an imaginary point directly above your head, the center of your personal hemispherical view of the universe. As you lie there, looking up, the sky forms a great dome, a hemisphere arching from one horizon to the other. And at the very top of that dome, directly above you, lies a special, personal point, the zenith. It is the center of your own unique celestial sphere. No one else, in their particular location on Earth, shares your exact zenith at this moment. It is the point where you are looking straight out into the universe, perpendicular to the ground beneath you. As the Earth turns, different stars and planets will pass through your zenith, each one pausing for a moment at the very peak of your sky, the very center of your personal universe, before continuing their slow descent toward the horizon. The reason we have different constellations for different seasons is that as we orbit the Sun, our nighttime view of the galaxy shifts, like turning in a room. The parade of the constellations through the year is not random. It is a direct and beautiful consequence of our annual journey around the Sun. Imagine yourself standing in the center of a vast, dark room, with pictures on all the walls. A single bright lamp in the center represents the Sun. As you slowly walk in a circle around the lamp, your back to it, you see different walls of the room. In summer, we are on one side of the Sun, looking out into one direction of the galaxy, seeing the stars of Scorpius and Sagittarius. In winter, we have orbited to the opposite side, and our nighttime view is now of another part of space, revealing Orion and Taurus. We are not just watching the sky turn, we are changing our viewpoint within it, taking a grand year-long tour of our local galactic neighborhood. Some stars you see at night may have already died, their light still traveling to us long after the star itself has gone out. This is one of the most poignant and haunting truths of the night sky. The light from a star is a messenger, and its journey can take centuries, millennia, even millions of years. It is entirely possible that a brilliant, massive star whose light you see tonight actually exhausted its fuel and ended its life in a cataclysmic supernova explosion long ago. But the final photon of light from its peaceful existence is still in transit, a ghost of the star carrying the image of its former self across the light years. We are watching a cosmic history play out in real time, surrounded by the living memories of stars that may no longer be there, a gentle reminder of the lag between event and perception, between existence and memory on a galactic scale. The Hubble Space Telescope, orbiting above our atmosphere, can see galaxies so far away their light has been traveling for over 13 billion years. Far above the distorting blanket of our atmosphere, the Hubble Space Telescope floats in the pure silence of space. From its pristine vantage point, it can peer deeper into the universe than any ground-based telescope. It has taken photographs known as deep fields, where it stared at a seemingly empty patch of sky for days, gathering the faintest traces of light. And in that tiny, dark spot, it revealed not emptiness, but a universe teeming with thousands of galaxies, each a faint red smudge. The light from these galaxies has been traveling for over 13 billion years, showing us what the universe looked like when it was in its infancy, a cosmic toddler filled with young, forming galaxies. We are not just looking far away, we are looking back to the very dawn of cosmic time. The universe is expanding. Most galaxies are moving away from us, their light stretched into redder wavelengths, a silent cosmic retreat. In the early 20th century, astronomers made a discovery that forever changed our understanding of the cosmos. Nearly all galaxies are flying away from us and from each other. Space itself is stretching like the surface of an inflating balloon. This expansion causes the light from these distant galaxies to be stretched on its long journey to us, shifting it towards the red end of the spectrum. It is not that galaxies are racing through space, but that the fabric of space-time between them is growing. The entire universe is in a state of gentle, relentless growth, a quiet exhalation on a scale so vast it defies human imagination. The night sky is not static. It is an unfolding story, with every distant galaxy receding into an ever deeper silence. The craters on the moon are a historical record, preserved for billions of years in the airless silence, a testament to a violent early solar system. The face of the moon is a timeless archive, a pockmarked landscape that tells a story of a chaotic and violent past. Without wind, water, or tectonic activity to erode its surface, every impact from the last few billion years remains frozen in time. Each crater is a silent monument to a moment of immense collision when an asteroid or comet slammed into the lunar surface. The larger basins, like the Sea of Tranquility, are the scars of cataclysmic events that shaped the early solar system. When you look at the Moon, you are looking back into an era of cosmic bombardment, a period of chaos that has since given way to the profound, airless quiet that now defines our celestial companion. The Earth's axis is tilted. This simple fact is the reason we have seasons, a gentle rocking back and forth that brings summer bloom and winter quiet. The rhythm of our year, the predictable dance of spring, summer, autumn, and winter, arises from a single, graceful inclination. The Earth does not spin upright in its orbit. It is tilted at about 23.5 degrees, like a spinning top leaning to one side. As we journey around the Sun, this tilt means that first one hemisphere, then the other, is leaned towards the light, receiving more direct sunlight and longer days. This gentle, annual rocking motion is the metronome of life on our planet, governing the growth of crops, the migration of animals, and the very mood of our world. It is a cosmic reminder that even a slight tilt can create the most beautiful and essential cycles. There is a faint, constant glow in the night sky after twilight, called zodiacal light, caused by sunlight reflecting off interplanetary dust. Long after the last colors of sunset have faded from the western sky, a soft, ethereal glow sometimes appears, stretching upwards from the horizon along the path of the ecliptic. This is the zodiacal light, a pyramid of faint luminescence, often mistaken for the lingering twilight. It is not a phenomenon of our atmosphere, but of interplanetary space. It is sunlight, reflected and scattered by countless millions of tiny dust particles that float in the plane of our solar system, the scattered remains of asteroids and comets. This faint cosmic fog is a reminder that the space between planets is not entirely empty but filled with a fine, luminous dust, a silent, sunlit haze connecting the worlds. The star Sirius, the brightest in our night sky, is actually a binary system. Two stars locked in a mutual gravitational dance. That brilliant diamond-hard point of light in the constellation Canis Major is not one, but two stars. Sirius, the dog star, is a binary system. What we see is the brilliant white main sequence star, Sirius A, but circling it, invisible to the naked eye, is a faint, dense companion, Sirius B, a white dwarf star. This tiny, Earth-sized stellar remnant is all that remains of a once massive star that lived and died, and now it slowly orbits its brighter partner every 50 years. Even the simplest, most singular point of light can hold a hidden complexity, a silent, cosmic partnership playing out over eons. The concept of magnitude measures a star's brightness. The lower the number, the brighter the star, a scale invented by the ancient astronomer Hipparchus. To bring order to the heavens, the ancient Greek astronomer Hipparchus created a system for classifying stars by their brightness. He called it magnitude. The brightest stars were of the first magnitude, and the faintest visible to the naked eye were of the sixth. This system, though refined and made precise with modern technology, is still used today. it is a counterintuitive scale, where a lower number means a brighter object. The planet Venus can reach a magnitude of -4, and the full moon is -12. This ancient scale connects our modern gaze directly to the stargazers of millennia past, a continuous thread of human wonder, quantifying the luminous beauty of the night. The International Space Station, a symbol of human cooperation, orbits the Earth every 90 minutes. A slow, bright star drifting peacefully across the heavens. From your backyard, you can sometimes see a steady, non-twinkling point of light moving gracefully across the starfield. This is not a star or a planet, but a human outpost, the International Space Station. Circling our planet every 90 minutes, it is a testament to what humanity can achieve when we work together. Sunlight glinting off its vast solar panels makes it the third brightest object in our sky after the sun and moon. Watching its silent, purposeful passage is a profoundly peaceful experience, a reminder of human ingenuity and presence in the high frontier, a silent ship of explorers sailing the ocean of near-Earth space. The moon is slowly moving away from Earth at about the same speed your fingernails grow, a gentle cosmic drifting apart. The moon was once much closer to Earth, and the days were shorter. But the gravitational interactions between Earth and its companion have been, over billions of years, pushing the moon away. It recedes from us at a rate of about 3.8 centimeters per year, roughly the speed at which your fingernails grow. This is an imperceptible change on a human timescale, but over cosmic time, it is a significant and irreversible drift. In the far future, the moon will appear smaller in the sky, and total solar eclipses will no longer occur. It is a slow, gentle farewell, a gradual distancing in the cosmic dance between our world and its silent, loyal partner. The terminator line on the moon, the division between day and night, is where the shadows are longest and the landscape most dramatic. When you look at a crescent or half moon through a telescope, the line that separates the sunlit portion from the dark is called the terminator. It is here that the sun is rising or setting on the lunar landscape. Because the light strikes at a very low angle, the terrain along the terminator is cast into sharp, dramatic relief. Craters throw long, black shadows, and mountain ranges stand out in stark, brilliant clarity. It is the most dynamic and detailed region of the moon, a place of endless sunrise and sunset, where the rugged, airless topography is revealed in its most raw and beautiful form. There are more stars in the universe than grains of sand on all the beaches on Earth, a number so vast it is a quiet thought to hold. This is a humbling, almost incomprehensible fact. Astronomers estimate there are roughly 100 billion galaxies in the observable universe, each containing billions or even trillions of stars. The total number of stars is a number with more than 20 zeros. It is a figure so large that it exceeds the number of all the grains of sand on every beach, in every desert, on our entire planet. The next time you stand on a beach and feel the countless grains of sand between your toes, remember that the cosmos above contains even more suns, each a potential sun for other worlds, other possibilities. It is a number that speaks not of emptiness, but of unimaginable silent abundance. The star Betelgeuse in Orion is a red supergiant, so large that if it replaced our Sun, its surface would extend past the orbit of Jupiter. Within the familiar shape of Orion the Hunter, his right shoulder is marked by a distinct reddish star, Betelgeuse. This is no ordinary star. It is a red supergiant, a star in the final stages of its life, having swollen to a monstrous size. If you were to place Betelgeuse at the center of our solar system, its tenuous outer atmosphere would engulf the orbits of Mercury, Venus, Earth, Mars, and extend far beyond, well into the asteroid belt, nearly reaching Jupiter. Our entire inner solar system would exist inside this single dying star. It is a breathtaking illustration of scale, a leviathan of the cosmos that appears as a mere, gentle, ruby point in our winter sky, a silent reminder of the dramatic and colossal ends that await some stars. The summer triangle is not a constellation, but an asterism, a simple, bright pattern of 3 stars from 3 different constellations. High in the summer sky, 3 brilliant stars form a vast, nearly perfect geometric shape, the summer triangle. Yet, this prominent pattern is not an official constellation. It is an asterism, a recognizable pattern of stars that forms part of a larger constellation, or borrows from several. The 3 stars, Vega in Lyra, Deneb in Cygnus, and Altair in Aquila, are each the brightest jewels of their own respective constellations. They are not physically connected, but from our vantage point on Earth, they form a celestial triangle that is far more noticeable and grand than the individual constellations they belong to. It is a lesson in perspective, showing how our human minds can create familiar shapes from the scattered, 3-dimensional reality of the galaxy. The planet Mercury has no atmosphere to speak of, so its sky is perpetually black, even during the day, with the sun a blinding white hole. Imagine standing on the surface of Mercury, the innermost planet. The sun appears 3 times larger in the sky than it does from Earth. But above you, the sky is not blue, but an inky, profound blackness, even at high noon. This is because Mercury is essentially airless. It lacks a substantial atmosphere to scatter sunlight and create a blue sky. The stars and planets would be visible night and day, unwavering points of light in the eternal darkness, while the sun itself would be a terrifyingly brilliant, silent, and sharp-edged beacon, a blinding white hole torn in the fabric of the black celestial sphere. It is a world of stark, violent contrasts, without the soft, comforting filter of a sky. The dust that makes up the dark lanes in the Milky Way is the same stuff that makes up you and me. Carbon, silicon, iron, forged in ancient stars. When you look at the Milky Way and see those dark, rippling lanes that seem to split the river of light, you are not looking at empty space. You are looking at cosmic dust. These are clouds of microscopic grains, composed of elements like carbon, silicon, and iron, all peppered with frozen ices. These very elements are the building blocks of rocky planets and of life itself. They were forged in the nuclear hearts of ancient stars and scattered across the galaxy when those stars died. The dust that obscures the galactic center is the same raw material that coalesced to form our Earth and our bodies. We are, in a very literal sense, looking at our own cosmic origins when we gaze upon those dark silhouettes against the starlight. The aurora borealis and aurora australis are Earth's way of responding to the sun as solar winds dance with our magnetic field at the poles. The shimmering ghostly curtains of green, red, and purple light that dance in the polar skies are not a phenomenon of this world alone. They are a conversation between the Earth and the sun. The sun constantly exhales a stream of charged particles, the solar wind. When this wind encounters Earth's magnetic field, it is funneled towards the magnetic poles. There, it energizes atoms and molecules in the upper atmosphere, causing them to emit light, much like a neon sign. The aurora is our planet's beautiful, silent response to the sun's constant, invisible breath, a luminous proof that we are living within the sun's extended, dynamic atmosphere. The moon's gravity pulls on the Earth, creating the ocean's tides, a slow, rhythmic breathing of the seas, in and out, day after day. The gentle, relentless pull of the moon's gravity does not just keep it in orbit, it stretches the Earth itself. The solid ground flexes slightly, but the oceans, fluid and free, respond dramatically. They bulge out towards the moon and on the opposite side of the Earth, creating two high tides each day. As the Earth rotates, this watery bulge moves around the planet, causing the sea to rhythmically advance and retreat along the coastlines. The slow, predictable breathing of the tides is the most visible and tangible evidence of a celestial body's influence on our world. It is a cosmic connection you can witness from the shore, a silent, gravitational dance between Earth and her companion. There are worlds with multiple suns. Planets orbiting binary stars would see double sunsets, their skies a perpetual dance of light and shadow. For a long time, double sunsets were the stuff of science fiction. But we now know that planets can and do form around binary star systems. On such a world, your sky might be illuminated by two stars of different colors, orbiting one another in a slow, celestial waltz. Your days would be complex, with shifting light patterns, double shadows, and sunsets where first one star, then the other, dips below the horizon. Some planets might even orbit in a wide circumbinary path around both stars. The universe, it seems, is far more imaginative than we once dreamed, crafting skies of breathtaking complexity and beauty around other suns. The Oort cloud is a theoretical shell of icy objects far beyond Pluto, the source of long-period comets, a distant frozen reservoir. The solar system does not end with Pluto, or even with the Kuiper Belt. Far, far beyond, a full light year away, a vast, spherical shell of icy planetesimals is thought to exist. The Oort cloud. It is the true frontier of our solar system, a gravitational reservoir containing trillions of icy bodies, some as large as mountains. Occasionally, the gravitational nudge from a passing star or the galactic tide will dislodge one of these icy chunks, sending it on a fall inward towards the sun. As it approaches the inner solar system, it heats up, blossoming into a magnificent comet with a brilliant tail. Every long-period comet is a messenger from this distant, frozen, and silent realm, a visitor from the deepest, darkest reaches of our own solar backyard. A blue moon is not actually blue. It is simply the second full moon in a single calendar month, a rare but regular occurrence. The phrase, "once in a blue moon," suggests an event of extreme rarity. But in astronomy, a blue moon is not particularly rare, nor is it blue. It is a quirk of our calendar. The time between full moons is about 29.5 days, while most of our months are longer. This discrepancy occasionally allows for two full moons to squeeze into a single calendar month. The second one is dubbed the blue moon. It is the same beautiful silvery moon as any other night, a trick of the calendar rather than a change in the moon itself. It is a gentle reminder of the imperfect but beautiful fit between our human-made timekeeping and the timeless cycles of the cosmos. The light from the most distant galaxies is stretched so much by the expansion of the universe that it arrives not as visible light, but as infrared or radio waves. As the universe expands, it stretches not only space, but the very light traveling through it. For light from the most incredibly distant galaxies, this stretch is so extreme that its wavelength is pulled from the visible part of the spectrum far into the longer, invisible wavelengths of infrared light and even radio waves. What was once visible, brilliant starlight, has been redshifted into a form our eyes cannot see. This is why telescopes like the James Webb are designed to see in infrared, to undo this cosmic stretching, to translate these long, tired waves back into a picture we can understand, allowing us to see the infant galaxies as they were when their light first began its journey. The phases of the moon are caused by the changing angles between the Earth, the moon, and the sun. A slow, predictable cycle of light and shadow. Each night, the moon presents a slightly different face to us, a slender crescent, a half-disk, a glowing full sphere. This is not a change in the moon itself, but the grandest play of light and shadow in our solar system. The sun always illuminates half of the moon. But as the moon makes its month-long journey around the Earth, we view this sunlit half from a constantly shifting perspective. At the new moon, the illuminated side is turned completely away from us, and the moon vanishes into the starry background. Then, night by night, a sliver of light appears, the terminator line creeping across the seas and craters, revealing more and more of its surface, until the entire face is bathed in light at the full moon. It is a celestial clock, ticking with a serene, soothing predictability, an eternal, slow breath of light that has guided the rhythms of life on Earth for billions of years. The planet Mars appears red because its surface is rich in iron oxide, rust, a whole world slowly weathering under a thin, cold atmosphere. That fiery red eye staring down from the constellations of Scorpius or Sagittarius is Mars, the red planet. Its color is not an optical illusion, but a testament to its nature. The Martian surface is covered in fine dust, rich in iron. Over billions of years of exposure to a thin atmosphere containing traces of water, this iron has oxidized, it has rusted. Mars is essentially one giant, desert-like, rusted rock. Its reddish hue is the color of cosmic rust, a quiet, slow-motion process that has painted an entire world in the color of blood and fire, creating one of the most distinctive sights in our night sky, a silent, ruddy beacon that has captivated the human imagination since the dawn of time. There are clouds in space. Vast nebulae, like the Orion Nebula, are stellar nurseries where new stars are being born from gas and dust. What seems like empty space between the stars is often something far more substantial. Nebulae are cosmic clouds, enormous, unimaginably diffuse collections of gas and dust, stretching across dozens or hundreds of light years. Some, like the Orion Nebula, visible as a faint fuzzy patch in the hunter's sword, are stellar nurseries. Within their cold, dark interiors, pockets of gas collapse under their own gravity, heating up until nuclear fusion ignites and a new star is born. These clouds are the cradles of solar systems, the vibrant, chaotic, and beautiful birthplaces of suns. They remind us that the cosmos is not a static museum, but a dynamic, living entity, constantly creating, constantly giving birth to new light in the silent, dark voids. The cosmic microwave background is the faint afterglow of the Big Bang, a whisper of radiation that fills all of space, the oldest light we can detect. If you could tune a television to the static between stations, a small fraction of that snow is the oldest signal in the universe. It is the cosmic microwave background, the faint, cold afterglow of the Big Bang itself. This radiation is a relic from a time, 13.8 billion years ago, when the universe was a hot, dense, opaque soup of particles and energy. As it expanded and cooled, it became transparent, and that first burst of light has been traveling ever since, stretched and cooled by the expansion of the universe into a faint microwave whisper. It is the fossilized light of creation, a uniform glow that permeates every cubic inch of space, a silent echo of the universe's violent and magnificent birth, and the foundation upon which all later structures, stars, galaxies, us, would be built. The star Algol, in Perseus, is known as the demon star because it visibly dims every few days as a dimmer companion star eclipses it. In the constellation Perseus, there lies a star named Algol, from the Arabic for the demon's head. For most of the time, it shines steadily, but every 2.87 days, for a period of about 10 hours, its brightness noticeably fades. The ancient observers saw this as a winking, malevolent eye. We now know the truth. Algol is not one star, but two, locked in a close gravitational embrace. The brighter star is periodically eclipsed by its larger but dimmer companion, causing the overall light we see to drop. It is a binary system, a cosmic clockwork of mutual orbits and eclipses, a demonstration that even the fixed stars can have their rhythms and cycles, a slow, predictable blink in the eye of the demon, a quiet dance of shadows across the light years. The Earth's rotation is gradually slowing down due to the tidal pull of the moon, making our days very, very slowly longer. The rhythm of our lives, the 24-hour cycle of day and night, is not a permanent constant. It is slowly, imperceptibly changing. The gravitational tug-of-war between Earth and the Moon acts as a brake on our planet's spin. The energy lost slows the Earth's rotation, making each day a tiny fraction of a second longer over a century. Hundreds of millions of years ago, a day was only 22 hours long, and a year contained over 400 days. The Moon, in turn, uses this energy to spiral slowly away from us. It is a grand, slow transfer of energy and momentum, a cosmic dance where the partners gradually distance themselves and slow their spin, a process that will continue until Earth's day and month are equal in length, a final, synchronized state billions of years in the future. The local group is our galactic neighborhood, a collection of over 50 galaxies, including Andromeda and our own Milky Way, bound by gravity. Our Milky Way does not float in solitary splendor. It is part of a small, gravitationally bound family of galaxies known as the local group. This cosmic archipelago spans over 10 million light-years and contains more than 50 members. The two great spirals, Andromeda and the Milky Way, are the dominant giants, each with its own entourage of smaller satellite galaxies, like the large and small Magellanic Clouds. The rest of the group is made up of smaller, fainter dwarf ellipticals and irregular galaxies. We are not isolated. We are part of a community, a quiet, widely spaced cluster drifting together through the vastness of intergalactic space, bound by the invisible threads of shared gravity. A neutron star is the incredibly dense remnant of a supernova, where a star's mass is crushed into a sphere just a few miles across. When a massive star ends its life in a supernova explosion, its core does not always vanish. Sometimes it collapses into one of the most extreme objects in the universe, a neutron star. The gravity is so intense that protons and electrons are crushed together, forming neutrons. All the mass of a star larger than our Sun is compressed into a perfect sphere, no bigger than a city. A single sugar cube-sized piece of neutron star material would weigh billions of tons on Earth. These objects spin rapidly, often many times per second, and possess immense magnetic fields. They are the ultimate state of dense matter, a cosmic atom, a testament to the sheer crushing power of gravity and a silent, invisible tombstone for a once giant star. The green flash is a rare optical phenomenon, sometimes seen just as the sun dips below the horizon, a fleeting emerald spark. For a brief second, under perfect atmospheric conditions, as the very last sliver of the sun disappears below a distant, sharp horizon, you might be gifted with one of nature's most elusive sights, the green flash. This is not a myth. It is a real atmospheric refraction phenomenon. As sunlight passes through the increasing thickness of the atmosphere near the horizon, it is bent or refracted. The atmosphere acts like a weak prism, slightly separating the colors. Blue and green light are bent more than red and orange. Often, the blue light is scattered away, leaving a brilliant, surreal green spot to appear for just a second or two. It is a moment of pure, transient magic, a celestial emerald winking at you from the edge of the world. before the night fully takes hold. The sky is full of exoplanets, worlds orbiting other stars. We have discovered thousands, and statistically, nearly every star has at least one planet. For most of human history, we knew of only the planets in our own solar system. Now, we know the cosmos is filled with worlds. They are called exoplanets, and we have discovered thousands of them, with new ones found almost every day. They come in every conceivable form: hot Jupiters, super-Earths, mini Neptunes, and even planets orbiting the corpses of dead stars. The statistics from these discoveries point to a staggering conclusion. There are likely more planets in our galaxy than there are stars. Nearly every star you see at night is a sun, and almost certainly it is accompanied by a family of worlds. The universe is not just a collection of lonely lights, but a vast tapestry of solar systems, many of which may hold rocky planets in habitable zones, silently orbiting in the quiet of space, each a potential home for something or someone. The Milky Way is our home galaxy, a barred spiral of stars, and we live in a quiet suburb, the Orion Spur, between two major arms. When you look at that hazy, luminous river arching across the sky, you are looking at the plane of our own galactic home, the Milky Way. It is a vast, barred spiral galaxy, a colossal pinwheel of hundreds of billions of stars, gas and dust, all slowly turning in the gravitational embrace of dark matter. And our place within it is not at the center, nor in the thick of the action. We reside in a quieter, minor stellar lane called the Orion Spur, nestled between the two great spiral arms of Perseus and Sagittarius. This peaceful suburban location, far from the crowded and violent galactic core, may have been crucial for the development of life on Earth, offering a stable, relatively safe environment for billions of years. We are citizens of a quiet neighborhood in a metropolis of stars. The great red spot on Jupiter is not only a giant storm, but it is also shrinking, slowly fading after centuries of observed fury. For over 3 centuries, astronomers have been watching the Great Red Spot, a colossal anticyclonic storm in Jupiter's southern hemisphere, large enough to swallow Earth whole. It is a tempest of unimaginable power, with winds screaming at speeds that defy comprehension. But this iconic feature is changing. Observations over the past 100 years show that the storm is gradually shrinking, its oval shape becoming more circular, its fierce red color sometimes fading to a pale salmon hue. While it will likely remain a massive storm for many years to come, it is a reminder that even the most permanent-looking features in our solar system are dynamic, evolving, and transient. We are witnessing the slow, gentle fading of a legendary cosmic hurricane. The Perseid and other meteor showers happen when Earth passes through the debris trail left behind by a comet, a celestial cleanup. Those beautiful fleeting streaks of light that grace our skies on certain nights each year are not random events. They are meteor showers, like the famous Perseids in August or the Geminids in December. They occur when the Earth, on its orbit around the Sun, plows through a cloud of dusty debris left behind by a comet. As these tiny particles, often no larger than a grain of sand, slam into our atmosphere at tremendous speeds. They vaporize in a flash of light, a shooting star. It is a gentle, luminous rain of cosmic dust, the remains of a frozen visitor from the outer solar system, burning up in a final, brilliant display. We are watching the slow dissipation of a comet's trail, a beautiful and harmless celestial cleanup. The habitable zone is the region around a star where temperatures might allow for liquid water to exist on a planet's surface, a potential for life, also known as the Goldilocks zone. This is the orbital distance from a star where it is not too hot and not too cold, but just right for liquid water to potentially pool on a rocky planet's surface. Water is the universal solvent, the medium in which the chemistry of life as we know it is possible. Finding planets within their star's habitable zone is one of the most exciting pursuits in astronomy, as it narrows down the search for worlds that could harbor life. Our Earth orbits snugly within the Sun's habitable zone. This delicate, life-giving balance is a reminder of the precise and fragile conditions that allow a world to bloom with biology, a special region of warmth in the cold vastness of space. The Van Allen belts are zones of charged particles held by Earth's magnetic field, protecting us from the harshest of the solar wind. Invisible to our eyes, but crucial to our existence, are two great donut-shaped regions of intense radiation that surround our planet, the Van Allen belt. They are created by Earth's magnetic field, which traps and holds charged particles from the solar wind. These belts act as a protective shield, deflecting and capturing this harmful radiation, preventing it from scouring the surface of our world and making life impossible. They are a natural magnetic force field, a testament to the dynamic and protective nature of our planet. When astronauts travel beyond low Earth orbit, they must pass through these belts quickly or be shielded, a reminder of the invisible, energetic environment that our planet so gracefully manages for us. The Doppler effect is what allows us to know stars and galaxies are moving by the slight shift in the color of their light. We can tell if a star or galaxy is moving toward us or away from us simply by analyzing its light. This is thanks to the Doppler effect, the same phenomenon that causes the pitch of a siren to change as it races past you. When a light source moves away from us, its light waves are stretched, making them appear redder. This is redshift. When it moves toward us, the waves are compressed, making the light blue shift. By measuring this subtle shift in the familiar spectral lines of starlight, astronomers can calculate the velocity of celestial objects. It is this very principle that revealed the expansion of the universe, allowing us to listen to the motion of the cosmos through the silent language of light. The zenith is the point in the sky directly above your head, the center of your personal hemispherical view of the universe. As you lie back and gaze upward, the sky forms a great dome, a hemisphere arching from one horizon to the other. And at the very top of that dome, directly above you, lies a special personal point, the zenith. It is the center of your own unique celestial sphere. No one else, in their particular location on Earth, shares your exact zenith at this moment. It is the point where you are looking straight out into the universe, perpendicular to the ground beneath you. As the Earth turns, different stars and planets will pass through your zenith, each one pausing for a moment at the very peak of your sky, the very center of your personal universe, before continuing their slow descent toward the horizon. The nadir is the point directly beneath your feet, through the body of the Earth, a reminder that the sky is all around us. For every point above, there is a corresponding point below. The nadir is the astronomical term for the point directly opposite the zenith. It is the direction straight down through the body of the Earth and out the other side into space. While we cannot see it, it is a conceptual anchor, completing the celestial sphere that surrounds us. It reminds us that the sky is not just up, but is a full sphere enveloping our world. At this very moment, for someone on the exact opposite side of the planet, your nadir is their zenith, and they are looking up at the stars that lie directly beneath your feet. We are all suspended at the center of our own cosmic bubble, with stars in every conceivable direction. A day on Venus is longer than its year. It takes longer for Venus to rotate once on its axis than to orbit the Sun. Venus is a world of cosmic paradoxes. It takes Venus only about 225 Earth days to complete one orbit around the Sun. That is, its year. But it takes a staggering 243 Earth days to complete a single rotation on its axis. That is, its day. This means a day on Venus is longer than its year. Furthermore, it rotates in the opposite direction to most planets. So on Venus, the Sun would rise in the west and set in the east. This sluggish retrograde spin is likely the result of a colossal impact in the distant past or gravitational interactions with the Sun. Venus is a reminder that the rhythms of other worlds can be strange and alien, governed by a history of violence and celestial mechanics far different from our own. The Kuiper Belt is a disk of icy bodies beyond Neptune, home to Pluto and other dwarf planets, a frozen frontier of our solar system. Beyond the orbit of Neptune lies a vast, disc-shaped region known as the Kuiper Belt. It is a cosmic junkyard filled with countless icy bodies, remnants from the formation of the solar system. This is the realm of the dwarf planets, including Pluto, Haumea, and Makemake. These are not barren rocks, but complex worlds with icy geology, possible subsurface oceans, and tenuous atmospheres that freeze and fall as snow when they are far from the Sun. The Kuiper Belt is our solar system's attic, a deep freeze preserving the pristine ancient building blocks that never coalesced into a major planet, a frontier zone that is only now beginning to reveal its secrets. The equinox happens twice a year, when day and night are of nearly equal length all over the world, a moment of perfect balance. There are two special days each year, one in March and one in September, when the Sun crosses the celestial equator. On these days, known as the equinoxes, the Earth's axis is tilted neither toward nor away from the Sun, resulting in nearly equal portions of day and night across the entire globe. It is a moment of celestial equilibrium, a brief, perfect balance between light and darkness. For a fleeting day, the planet finds a symmetrical harmony. The equinox is a reminder of the graceful geometry of our planet's journey, a time of global balance that has been marked by cultures for millennia as a turning point in the seasons, a silent pause in the Earth's eternal rocking motion. The solstice marks the longest and shortest days of the year, the sun reaching its highest and lowest points in our sky. If the equinox is a point of balance, the solstice is a point of extremity. Occurring in June and December, the solstices mark the days when the sun reaches its maximum and minimum declination in the sky. The summer solstice brings the longest day and the shortest night, with the sun arcing high overhead. The winter solstice brings the longest night and the shortest day, with the sun hanging low and weak in the sky. These are the turning points, the moments where the sun's apparent journey north or south halts and reverses course. They are the profound, cyclical markers of the Earth's tilt, dictating the rhythm of light and warmth, and have always been celebrated as powerful symbols of death and rebirth, of the enduring return of the light after the deepest darkness. The precession of the equinoxes is the slow 26,000-year wobble of Earth's axis, like a spinning top, gradually shifting our pole star. The Earth's axis is not fixed in space. It slowly wobbles, much like a spinning top, as it begins to slow down. This grand, majestic motion is called precession, and it takes approximately 26,000 years to complete a single cycle. This slow wobble causes the position of the equinoxes to shift gradually westward along the ecliptic, and it changes which star serves as our North Pole star over millennia. Polaris is our current guide, but in a few thousand years, it will not be. This imperceptibly slow dance means that the entire star field, the backdrop of the celestial sphere, is in a gentle, eternal drift against the calendar of our seasons. It is the slowest heartbeat of our planet, a cosmic rhythm felt over ages, not years. The zodiac is a belt of constellations through which the sun, moon, and planets always travel, a celestial stage for their motions. The planets and the moon do not wander randomly across the sky. Their paths are confined to a narrow band, about 16 degrees wide, centered on the ecliptic, the sun's apparent path. This band is the zodiac, and it is divided into 12 constellations, familiar names like Aries, Taurus, and Gemini. As we look up, we are looking at this celestial highway. The sun, moon, and planets are always found within this belt, performing their slow dances against this fixed backdrop of star patterns. It is a stage, and these wanderers are the players, their movements predictable and confined to this ancient starry path that has guided human imagination and timekeeping for thousands of years. The apparent magnitude is how bright a star looks from Earth. The absolute magnitude is how bright it truly is, a measure of its real power. The brightness of a star in our sky can be deceiving. A star might look bright because it is intrinsically brilliant, or simply because it is very close. To untangle this, astronomers use two scales. Apparent magnitude is simply how bright a star appears to us on Earth. Absolute magnitude, however, is a measure of its true intrinsic brightness, how bright it would appear if it were placed at a standard distance of 32.6 light-years from Earth. This allows us to compare the true luminous power of stars, revealing the distant, feeble giants and the nearby modest dwarfs. It is a way of seeing past the illusion of distance to understand the true nature of the suns that light the cosmos. The photon, a particle of light, can travel for billions of years across the vacuum of space, completely undisturbed until it meets your eye. The light from the stars is not a continuous wave, but a stream of countless tiny packets of energy called photons. Once created in the nuclear furnace of a star, a photon can embark on an epic journey across the universe. For billions of years, it may travel through the perfect vacuum, untouched, unchanged, a perfect messenger from the past. It does not age. It does not slow down. It exists in a state of pure travel until its journey ends in a final, fleeting moment, when it is absorbed by a molecule in your retina, translating its ancient energy into an electrical signal that your brain interprets as a point of light in the darkness. That starlight you see is a direct physical connection, a particle that has traveled across time and space for the sole purpose of meeting you. The corona of the sun, its outer atmosphere, is paradoxically hotter than its surface, a mystery that scientists are still unraveling. During a total solar eclipse, when the moon perfectly covers the brilliant face of the sun, its outer atmosphere is revealed. The corona, a beautiful, pearly white, wispy halo of plasma. This ethereal light holds a deep mystery. While the sun's visible surface, the photosphere, is about 5,500 degrees Celsius, the corona soars to temperatures of over 1,000,000 degrees. How the solar atmosphere gets so much hotter than the surface below is one of the great unanswered questions in solar physics. It is thought that the sun's powerful magnetic fields somehow channel energy upward, heating the plasma to incredible temperatures. The corona is a beautiful, ghostly reminder that even our own star holds profound secrets, a veil of superheated mystery surrounding the familiar light of our day. The space between galaxies is almost incomprehensibly vast. If galaxies were the size of apples, they would be separated by miles. We often see pictures of galaxies clustered together, but this is an illusion of scale. The emptiness between galaxies is, on average, millions of light years across. To put it in perspective, if you shrunk the Milky Way, a galaxy of hundreds of billions of stars, down to the size of an apple, the nearest similar-sized galaxy, Andromeda, would be another apple about 600 miles away. The cosmos is, for the most part, a breathtakingly empty void. The galaxies are like rare, isolated islands in an ocean of nothingness so vast it defies human comprehension. This immense, dark space is the true backdrop of the universe, a silent, empty canvas that makes the glittering islands of stars all the more precious and lonely. The dark side of the moon is a misnomer. It is the far side, which gets just as much sunlight as the side we see. We just never see it from Earth. Due to a phenomenon called tidal locking, the moon rotates on its axis in exactly the same time it takes to orbit the Earth. This means we only ever see one face, the near side. The other hemisphere is perpetually turned away from us, and is often incorrectly called the dark side. But it receives just as much sunlight as the side we know. When we have a new moon, the far side is in full sunlight. It is not a place of perpetual darkness, but of perpetual mystery, a landscape we never saw until the space age, one that is surprisingly different, with a thicker crust and fewer of the dark volcanic seas that characterize the face it shows to us. It is a hidden hemisphere, a silent partner in our cosmic dance, always present, but forever just out of view. The Lagrange points are places in space where the gravitational pulls of two large bodies balance, creating pockets of stability. In any orbital system, like the Earth and the Sun, there are 5 special points in space where the gravitational forces and the orbital motion perfectly balance. These are Lagrange points. An object placed at one of these points will tend to stay there, relative to the 2 larger bodies. They are like gravitational sweet spots. The L1 point between Earth and the Sun is a perfect place for solar observatories. The L2 point behind Earth, as seen from the Sun, is where the James Webb Space Telescope resides, in a stable, cold vantage point. These points are cosmic parking spots, serene and stable locations in the otherwise dynamic and relentless pull of gravity, offering silent, balanced havens for our spacecraft to observe the universe. The James Webb Space Telescope sees primarily in infrared light, allowing it to peer through cosmic dust and see the first galaxies to form. Orbiting 1 million miles from Earth, the James Webb Space Telescope is not just a larger version of Hubble. It is a time machine designed to see in heat. Its primary mission is to observe the universe in infrared light, the light of warmth and redshift. This allows it to do 2 extraordinary things. First, to peer through vast clouds of interstellar dust that block visible light, revealing the hidden cradles of star birth. Second, and most profoundly, to see the light from the very first stars and galaxies, which has been stretched into the infrared part of the spectrum by the expansion of the universe. It is showing us the cosmic dawn, the moment when the first lights in the universe flickered on after the Big Bang, a silent witness to the infancy of everything. The speed of light, 300,000 kilometers per second, is the ultimate speed limit of the universe, a constant that governs cosmic distances. In our universe, nothing can travel faster than light in a vacuum. This speed, approximately 300,000 kilometers per second, is more than just a number. It is a fundamental constant, a rule woven into the fabric of space-time itself. It is the reason the universe has a horizon, a limit to what we can see. It defines the scale of the cosmos, turning light years into a measure of both space and time. This ultimate speed limit means that when we look out into space, we are always looking back into the past. It is a universal regulator, ensuring cause and effect, and creating the beautiful, delayed tapestry of the night sky that we observe from our small world. A black hole is a region of space where gravity is so strong that not even light can escape. A silent, dark knot in space-time. Imagine a place where gravity has won completely. A place where matter has been compressed into an infinitely dense point, a singularity, and the gravity around it is so overpowering that the velocity needed to escape it exceeds the speed of light. Since nothing can go faster than light, nothing, not even light itself, can ever leave. This is a black hole. It is a rupture in the fabric of space-time, a perfect dark sphere from which there is no return. They are the ultimate endpoints of gravity, the silent, invisible ghosts of dead massive stars, or the monstrous engines at the hearts of galaxies, around which the rest of the universe must silently and forever flow. The event horizon is the point of no return around a black hole, a boundary beyond which all knowledge of the interior is lost. The black hole itself is the singularity, a point of infinite density, but it is shrouded by a boundary called the event horizon. This is not a physical surface, but a mathematical threshold. Once an object crosses this invisible line, its fate is sealed. It cannot stop. It cannot turn back. It cannot send any signal out. It will be pulled inevitably toward the singularity. For the outside universe, the event horizon is a veil of perfect blackness. Any information about what falls in is lost forever, a one-way street into the ultimate unknown. It is the point where the known laws of physics, as we understand them, break down, a silent and absolute cosmic frontier. The pale blue dot is a photograph of Earth taken from billions of miles away by Voyager 1, a tiny, fragile speck in the void. In 1990, as the Voyager 1 spacecraft was leaving the solar system, it turned its camera back towards home for one last look. From a distance of 3.7 billion miles, it captured an image of Earth. Our world appears not as a globe of continents and oceans, but as a single pale blue pixel, a mote of dust suspended in a sunbeam. In that single, humbling image, all of human history, every person who ever lived, every triumph and tragedy, every forest and ocean, all of it exists on that tiny, fragile speck. It is the ultimate portrait of humility, a reminder that our home is an inconceivably small and precious oasis in the vast, dark, cosmic ocean. The cosmic web is the large-scale structure of the universe, with galaxies strung along filaments of dark matter like pearls on a necklace. The universe is not a random scatter of galaxies. On the larger scales, it has a structure, an architecture. This is the cosmic web. Vast, thread-like filaments of invisible dark matter stretch across billions of light years, forming a labyrinthine structure. At the intersections of these filaments, great clusters of galaxies gather, like glittering metropolises. Between them are immense, nearly empty voids. The galaxies we see are just the visible tracer, the luminous icing on this invisible, dark matter cake. This grand, web-like structure is the result of the universe's evolution under gravity, a breathtakingly beautiful and complex pattern that is the true, large-scale skeleton of the cosmos. The anthropic principle is the philosophical observation that the universe's physical constants seem finely tuned to allow for our existence. The fundamental constants of the universe, the strength of gravity, the force of the nuclear interactions, the mass of the electron, seem to be perfectly calibrated. If they were even slightly different, atoms would not be stable, stars would not burn, and life as we know it could never have arisen. This observation is known as the anthropic principle. In its simplest form, it states that the universe must be compatible with the conscious life that observes it. Some see this as mere coincidence, others as evidence for a multiverse where many universes with different constants exist, and we simply inhabit one that allows for us. It is a profound philosophical puzzle, written into the very laws of physics, a silent question about why the cosmos is so hospitable to observers like ourselves. The WOW signal was a strong, narrow-band radio signal detected in 1977 from space. It was never repeated, and its origin remains a mystery. For 72 seconds in 1977, a radio telescope at Ohio State University recorded a signal from space so powerful and so perfectly matched to the expected signature of an artificial extraterrestrial transmission that the astronomer who discovered it, Jerry Amon, circled the data printout and wrote "Wow" next to it. It came from the direction of the constellation Sagittarius, and it has never been detected again. Despite extensive searches, its origin remains one of the greatest unsolved mysteries in astronomy. It was a fleeting, brilliant shout in the cosmic silence, a one-time event that continues to tantalize and humble us, a reminder of how little we know and how vast the possibilities are. The Fermi paradox is the question of why, if the universe is so vast and old, we have not yet found any evidence of other civilizations. With hundreds of billions of stars in our galaxy, many billions of years older than the Sun, it seems statistically inevitable that other intelligent life should have arisen. So, the physicist Enrico Fermi famously asked, "Where is everybody?" This is the Fermi paradox. The silence of the cosmos, the lack of any clear evidence for other civilizations, is deeply puzzling. The potential answers range from the sobering, that intelligent life is exceedingly rare or self-destructs, to the hopeful, that space is vast and we are simply not listening correctly, or that advanced civilizations are simply too different for us to recognize. It is a paradox that holds a mirror to our own civilization and our future, a silent question hanging in the starlight. The Drake equation is a probabilistic formula used to estimate the number of active, communicative, extraterrestrial civilizations in our galaxy. In 1961, astronomer Frank Drake created a formula to structure the debate about the existence of extraterrestrial intelligence. The Drake equation multiplies together a series of factors: the rate of star formation, the fraction of stars with planets, the number of habitable planets per system, the fraction where life develops, the fraction where intelligence evolves, the fraction that develops technology, and the length of time such civilizations release detectable signals. Plugging in different estimates for these values yields wildly different results, from just one civilization, us, to millions. Its power is not in providing an answer, but in framing the question, showing us all the steps where life must succeed to become a voice in the cosmic chorus. It is a map of our ignorance and our hope. The Tunguska event was a massive explosion over Siberia in 1908, likely caused by a meteoroid or comet fragment exploding in the atmosphere. On a June morning in 1908, a remote region of Siberia was the site of a cataclysm. A fireball streaked across the sky, followed by an explosion so powerful it flattened 2,000 square kilometers of forest. The shockwave circled the globe twice. This was the Tunguska event, and it left no crater. The leading theory is that a small asteroid or piece of a comet, about 50 to 60 meters wide, entered Earth's atmosphere and detonated in a massive airburst before it could hit the ground. It was a dramatic reminder that our planet exists in a cosmic shooting gallery, and that the peaceful sky above can, on rare occasions, be the stage for events of immense, impersonal power. The ozone layer in Earth's atmosphere protects life by absorbing most of the sun's harmful ultraviolet radiation, a silent, life-preserving shield. High in the stratosphere, a thin, diffuse layer of a special molecule called ozone acts as our planet's sunscreen. This ozone layer absorbs the vast majority of the sun's harmful ultraviolet UV radiation. Without this invisible, protective veil, the surface of our world would be bombarded by UV rays capable of damaging DNA, causing widespread cancer, and preventing complex life from ever gaining a foothold. It is a fragile, crucial component of our atmosphere, a testament to the precise and delicate balance that makes our world a living one. It is a silent, gaseous guardian, always at work, high above the clouds. The geocentric model, which placed Earth at the center of the universe, was a natural but incorrect assumption held for centuries. For millennia, it seemed self-evident. The sun, moon, planets, and stars all appeared to circle around a stationary Earth. This geocentric, or Earth-centered model, was formalized by Ptolemy and dominated human thought for over 1,000 years. It was a beautiful, complex model of crystalline spheres and epicycles to explain the planet's curious motions. It placed humanity and its home at the cosmic center stage. While incorrect, it represented our first great, systematic attempt to understand the mechanics of the heavens, a grand intellectual edifice built from careful observation, even if its fundamental premise was an illusion born of our limited perspective. The heliocentric model, with the sun at the center, was a revolutionary idea that redefined our place in the cosmos, a humbling and beautiful truth. The work of astronomers like Copernicus, Galileo, and Kepler slowly dismantled the Earth-centered universe. They gathered evidence that the planets, including Earth, orbit the sun. This heliocentric model was a profound demotion for Earth and a monumental leap for human understanding. It showed that we inhabit a world in motion, a planet among planets, orbiting a star that is just one of countless others. It was a humbling realization, but also a liberating one, opening the door to modern astronomy and a true understanding of our place in a vast, sun-centered system. It was the moment we began to see the universe as it truly is, not as we presumed it to be. The celestial sphere is an imaginary sphere surrounding Earth, a useful concept for mapping the positions of stars and planets. To map the heavens, ancient astronomers imagined the stars fixed to the inside of a great rotating sphere centered on the Earth, the celestial sphere. While we now know this is not physically real, it remains an incredibly useful conceptual tool. It gives us a coordinate system for the sky with a celestial equator, poles, and meridians, allowing us to pinpoint the location of any object. It is the canvas upon which the daily motion of the stars is painted, a simplified model that, despite its inaccuracy, helps our earthbound minds navigate and comprehend the boundless, three-dimensional reality of space. The eclipse season is the period twice a year when the moon's orbit aligns with the sun and Earth, making solar and lunar eclipses possible. Eclipses do not happen every month because the moon's orbit is tilted about 5 degrees relative to Earth's orbit around the sun. For an eclipse to occur, the new moon for a solar eclipse or full moon for a lunar eclipse must happen when the moon is at or very near one of the 2 points where its orbit crosses the ecliptic plane. These periods, which occur in cycles about every 6 months, are called eclipse seasons. It is a precise celestial alignment, a brief window of opportunity when the sun, Earth, and moon can fall into a perfect or near-perfect line, casting shadows across space and creating the most dramatic and awe-inspiring events in our sky. A total solar eclipse is one of the most breathtaking sights in nature when the moon perfectly covers the sun, revealing its ethereal corona. There is nothing in nature quite like the day turning to night during a total solar eclipse. As the moon's shadow races across the Earth's surface for a few brief minutes, it perfectly blocks the brilliant face of the sun. The sky becomes a deep twilight blue, and the sun's outer atmosphere, the corona, bursts into view, a pearly white, wispy halo of plasma with delicate pink prominences clinging to the edge. Stars become visible in the middle of the day. The temperature drops. Animals fall silent. It is a moment of sublime, otherworldly beauty and profound awe, a temporary reunion of our world with its companion, creating a perfect and fleeting celestial alignment. The diamond ring effect is the brilliant flash of sunlight seen just before and just after totality in a solar eclipse, a moment of stunning beauty. In the final seconds before the moon completely covers the sun, and again in the moments as it begins to move away, a last brilliant bead of sunlight shines through a valley on the lunar limb. This creates the effect of a dazzling diamond set on a brilliant ring of light, the sun's corona. The diamond ring is a fleeting, breathtaking phenomenon, a final flash of the familiar day star before it is transformed into a black hole in the sky encircled by ethereal light. It is the dramatic opening and closing curtain on the main event of totality, a moment of pure celestial jewelry. The solar wind is a constant stream of charged particles flowing from the sun, shaping the magnetic environments of all the planets. The sun does not just give off light, it exhales. A constant supersonic flow of charged particles, mostly electrons and protons, streams outward from the sun's corona in all directions. This is the solar wind. It carries the sun's magnetic field throughout the solar system, creating a vast bubble of solar influence called the heliosphere. This wind shapes the magnetospheres of planets, compressing them on the sunward side and stretching them into long magnetic tails on the other. It is the solar wind that fuels the auroras and, during violent solar storms, can disrupt satellites and power grids on Earth. We live within the extended, dynamic, and invisible atmosphere of our star. The Voyager Golden Records are phonograph records aboard the Voyager spacecraft, carrying sounds and images of Earth into interstellar space. As the Voyager 1 and 2 spacecraft completed their grand tours of the outer planets, they began an endless journey into interstellar space. Attached to each is a golden record, a time capsule intended for any extraterrestrial intelligence that might find them. These records contain greetings in 55 languages, sounds of Earth, whales, wind, rain, laughter, music from different cultures, and 115 images encoded in analog form. They are a message in a bottle cast into the cosmic ocean, a testament to the curiosity, hope, and artistic spirit of a species on a small world, a quiet attempt to say, "We were here," to the silent stars. The universe is 13.8 billion years old, a number that contains all of history, from the first moment to this one, right now. Based on meticulous observations of the cosmic microwave background and the expansion rate of the universe, scientists have determined its age, 13.8 billion years. This number is the ultimate timeline. It encompasses the entire story of everything, from the Big Bang through the formation of the first atoms, the ignition of the first stars, the assembly of galaxies, the birth of the Sun and Earth, the rise of life, and the entire span of human history. All of it fits within these 13.8 billion years. It is a timescale that humbles our brief lives, yet connects us to an epic narrative of cosmic evolution that is our true, shared heritage. The Sun bobs up and down through the galactic plane as it orbits, a gentle wave motion over millions of years. Our Sun's path around the galaxy is not a flat, perfect circle. It also oscillates, or bobs, up and down through the plane of the Milky Way, much like a horse on a carousel. It takes about 64 million years to complete one full up and down cycle. This means we are currently not precisely in the galactic plane, but moving through it. Some scientists have speculated whether this motion and our passage through denser spiral arms could have long-term effects on Earth's climate and even evolution through subtle changes in cosmic ray flux or gravitational perturbations of comets in the Oort cloud. It is a grand, slow-motion wave we are all riding. We don't know what dark matter is, but we know it's there, shaping the cosmos from the shadows. The majority of the mass in the universe is invisible. We know it exists because of its gravitational pull. It holds galaxies together, bends light, and governs the formation of cosmic structure. But it does not emit, absorb, or reflect any light, hence the name dark matter. It is not made of atoms or any known particle. Its true nature is one of the greatest mysteries in science. It is the hidden skeleton of the cosmos, the invisible framework upon which the visible universe is built. We live in a world dominated by something we cannot see, a silent and mysterious presence that dictates the largest scale motions of the cosmos. There's more mass outside the disk of the galaxy than inside, in a vast, dark matter halo. When you picture the bright, starry disk of the Milky Way, you are only seeing a small fraction of its total mass. The majority of the galaxy's weight lies in an enormous, spherical halo of dark matter that extends far beyond the visible stars. This halo is the true gravitational anchor of the galaxy. Without its immense, invisible mass, the stars in the outer disk would fly off into intergalactic space. The luminous galaxy we see and love is just the bright, dense core of a much larger, darker, and more massive structure, a ghostly giant whose presence we can only feel, not see. The Milky Way's core may have flared as a quasar in the distant past, a brilliant, violent beacon. The supermassive black hole at our galaxy's center, Sagittarius A star, is quiet now, but there is evidence that it was once an active, brilliant monster. The presence of the Fermi bubbles and other features suggest that millions of years ago, it may have been a quasar, a voracious engine of light, feasting on infalling gas and shining with the power of 1,000 galaxies. If so, the center of our Milky Way would have been a terrifyingly bright beacon, visible across the universe. That time of violent activity has passed, leaving behind a quiet, slumbering giant, a reminder that even our gentle galaxy has had a more dramatic youth. The galaxy's structure changes over billions of years. Spiral arms shift and bars form and dissolve. Galaxies are not frozen sculptures. They are dynamic, evolving systems. Over billions of years, spiral arms can wind up tighter or unravel. Central bars can form from instabilities in the disk and then later dissolve. These changes are driven by gravitational interactions, internal dynamics, and mergers with other galaxies. The Milky Way you see today is not the one that existed 5 billion years ago, and it will not be the same 5 billion years in the future. Its beauty lies not in permanence, but in its slow, graceful evolution, a continuous cosmic dance of stars and gas on a timescale almost too vast to comprehend. Gravitational waves ripple through the galaxy from distant mergers, subtly shifting the fabric of space itself. When massive, compact objects like black holes or neutron stars spiral together and merge, they do not just create light, they shake the very fabric of space-time. These ripples are gravitational waves. They travel at the speed of light, stretching and squeezing space itself by tiny, almost imperceptible amounts as they pass through. Observatories like LIGO and Virgo have now detected these waves from many events. Even now, as you rest, faint whispers from colossal, ancient collisions are passing through your room, through you, subtly distorting the space you occupy. The universe is not silent. It is humming with these inaudible vibrations of gravity. Some stars orbit in elongated, tilted paths, relics of galactic mergers long ago. Not all stars in the Milky Way follow neat, circular orbits in the galactic plane. Some, particularly in the halo, move on highly elliptical and tilted paths. These stars are often refugees, the remnants of smaller dwarf galaxies that were torn apart and absorbed by the Milky Way billions of years ago. Their chaotic orbits are the gravitational fingerprints of these ancient acts of cosmic cannibalism. They are living fossils, their motion a silent testimony to the galaxy's violent and creative history of growth through collision, a story of ancient mergers written in the paths of these wandering stars. The Milky Way emits neutrinos we can barely detect, ghostly particles that pass through everything. Every second, trillions of nearly massless, chargeless particles called neutrinos pass straight through the Earth and through your body without a trace. Vast numbers of these ghost particles are produced in the nuclear reactions powering the Sun and in other cosmic events like supernovae. They are so elusive that they can travel through light years of lead without interacting. Detecting them requires enormous, sensitive experiments buried deep underground. These neutrinos are a direct sample of the nuclear fires at the heart of stars, a silent, invisible rain of messengers from the universe's most powerful engines, always passing through us, unnoticed. Interstellar space isn't empty. It's a turbulent sea of gas, dust, and magnetic fields. The space between the stars is not a perfect vacuum. It is filled with the interstellar medium, a thin, dynamic soup of gas, mostly hydrogen, dust grains, and energetic particles, all laced with magnetic fields. This medium is turbulent, with shock waves from supernovae carving out bubbles, and stellar winds sculpting vast structures. It is the raw material for new stars and the repository for the ashes of dead ones. It is a complex, evolving ecosystem, a cosmic ocean in which the stars are but temporary islands. What looks like empty, peaceful blackness is, in fact, a subtle, rippling, and ever-changing sea of matter and energy. And so, we have reached the end of our 100 facts, 100 glimpses into the infinite, 100 quiet thoughts whispered from the depths of space to drift away with into your dreams. Your mind has journeyed from the gentle, reflective glow of the moon to the very edges of the observable universe, from the birth of stars in turbulent, glowing nebulae to the silent, patient spin of distant galaxies. You have held vast, unimaginable distances in your mind and contemplated depths of time that dwarf human history. And now, it is time to let it all go. To release these facts, these numbers, these names and constellations. They have served their purpose, gently occupying your waking thoughts, easing the transition from the busyness of the day into the quiet, receptive peace of the night. There is no need to hold on to them anymore. Let them dissolve like mist. Let them fade into the background hum of the universe, a soft, cognitive murmur that soothes rather than stimulates. Bring your awareness back to the physical, to the present, to the safety of your room. Feel the quiet, steady weight of your body, fully and completely supported by your bed. Notice the soft texture of the sheets against your skin. Listen to the gentle, rhythmic sound of your own breathing, the most constant, the most comforting sound in your personal universe. In and out. The universe is vast, almost incomprehensibly so. But in this moment, your world is wonderfully small and safe and warm. This is your sanctuary. Outside your window, the cosmos continues its slow, silent, majestic dance, entirely without your effort. The stars will continue their grand arc across the sky. The planets will continue their patient wanderings. The light from distant galaxies will continue its long, lonely, and beautiful journey through the void. And you are now allowed to rest. You have full permission to let go completely, to surrender to the soft, welcoming embrace of sleep, knowing that the universe will keep turning, will keep shining, all on its own. Remember, you are stardust. You are a part of something so magnificent, so grand, that it can never be fully comprehended by the mind, but only felt by the soul. And as you sleep tonight, the cosmos continues its beautiful, silent, eternal dance, with you as a cherished, integral, and conscious part of it. Let your breathing slow even more, becoming deep and regular. Let your heart rate settle into a restful, sleepy rhythm. Let your thoughts dissolve into dreams of nebulas and quiet moons, of drifting through the silent, glittering rings of Saturn, of floating in the peaceful, weightless darkness between the stars. The night sky is watching over you. It has always been there, and it always will be. A constant, gentle, and luminous presence in the tapestry of your life. Sleep now. The universe is whispering its lullaby, a song written in the light of dead stars, a melody carried on the solar wind, a harmony played by the spinning of galaxies, all weave together just for you. Good night.